worldwide have mainly three applications. One is standby. Standby in the sense only when there is a power cut for a short duration of time the DG set comes into picture. So it is more of a rare application for the DG, rare running hours for the DG. Second is a prime application wherein you at least anticipate 3 to 4 hours of running of DG per day. So the rating of the DG is mainly taken for prime application. And the third one is continuous application for DGs, continuous running of DGs. So these are diesel generators which have been rated or designed so that they will run at least 12 hours in a day. So the whole process is dependent on DG set. There is no grid available in that area. So you might wonder where are those areas where DGs are running on a continuous basis. It is there are many industries which are in remote locations who depend fully on DG for running their pumps or running their other industrial equipments. Also, there are certain processes because of their criticality in nature, like in food, plastic, or in petrochemicals, where because it is so critical, and in that area there can be even voltage fluctuation. To avoid even voltage fluctuation, people don't want to take the risk and run DG to run that particular process alone continuously without the dependence on the grid. Even though grid might be available there, but the grid is not a stable grid. So even if there is a 1 second drop of grid and sudden shutdown of the plant, it will affect their whole batch of product which the process industry is producing. So to avoid that, they run DG continuously and hence incur a huge amount of cost. Now you know that the subsidy which was available for diesel generators and diesel price has been taken off slowly by the government, and the current price is as high as 60 rupees per litre, which is causing the unit electricity which is being used from diesel generators to be as high as minimum 15 rupees per unit, and in many cases depending upon the location, depending upon the capacity of the DG set, it is going as high as 22 rupees. So definitely depending on DG set is not economical now. It is definitely not going to be economical in future as the diesel prices keep on increasing. It's a limited resource, hence the price is only going to be on an upward trend. So how do we reduce our dependency on diesel and go for a green solution and which is also economical in nature? So as I said, mainly energy cost can come from our existing utility or the grid connection, which is also increasing day by day. On at least past few years, it has been increasing on a CAGR of 7% minimum, and currently most of the states are incurring a unit charge of 7 rupees per unit. Now diesel, it is as high as 21 rupees, and it is also increasing the past years at a CAGR of 6%. And what about renewable? The best advantage of renewable, even though the initial investment is high, there is no running cost. You only have, like if you take that of solar, it is depending upon the naturally available sunlight, and the amount of O&M charges which you are going to incur is very negligible when compared to the capex you have to put. It is hardly 1% of per annum of the capex which you invest. It's only the manual labor cleaning charges which will be required for cleaning the module so that there is no dust on the accumulating on the solar modules, and that too frequency is only once in a month or once in a fortnight, rarely. So definitely renewables are reaching grid parity, and there is more and more adoption of renewable energy, especially solar, across the world. Mr. Arun Kumar in the morning was explaining how the developed countries have adopted it in a much higher rate than in India. But in India also we have a good plan in terms of Jawaharlal National Solar Mission, where we are targeting at least 20 gigawatt by 2020. Definitely we are expecting that in principle implementation will be much more than that, because we are expecting the grid parity across sectors, whether it is commercial, industrial or residential will happen within 2 years of time. So the solar adoption is suddenly going to burst across the country. So this is how the solar PV system prices have gone down. As I said in the morning in the introduction speech, when we invested in solar way back in 2008-9, it was as high as 20 crores per megawatt. And when Sudhir was explaining about Gujarat solar power plants, the power capital investment at that time in 2011 was around 15 crores per megawatt. So the tariffs were equally higher at 15 rupees per unit given by the preferential tariff given by the government. But then continuously the price has come down, mainly because the module prices have come down in the past 5 years, and now we are hovering in the range of 7 to 8 crores per megawatt, a good quality plant. So As you can see, the prediction given, the grid parity is definitely going to come across sectors. Already grid parity is there in many states for commercial and industrial consumers. You will not believe in Maharashtra, people are paying as high as 15 rupees per unit only for the electricity to the utility, that is the private discoms like Tata, Reliance, etc. And otherwise, if it is Maharashtra State Electricity Board, they are paying around 7 rupees minimum. Now, in similar another state where the grid prices or the EB prices are very high is Andhra. So already for Andhra Pradesh consumers, commercial and industrial consumers, the grid parity is already achieved. You don't have to even depend on diesel generator. Otherwise, also you can go for a solar investment. But it becomes more necessary in Andhra. In Maharashtra, there is hardly power cut. They are having, the industries have express feeders and they have continuous power supply day and night. But that is not the case in AP. In AP, as I understand, based on interaction with various customers, there is definitely power holidays and also power cuts on a daily basis of at least 4 hours. So it becomes it becomes a no-brainer for anybody to invest in solar, and especially it becomes important to have a solution of solar which is not only which can work stably with that of the grid, but also with that of the diesel generator. Why it is technically important, I will come in the subsequent slides. So the PV system cost has decreased more than 50% in the last 3 years. Fuel cost of DG sets is on a continuous increase basis. So there is a significant cost advantage for going into PV, and this will become even more so in the coming years. So that's what I was saying. What is a hybrid system? Why was I stressing upon the point of the technical challenges involved when you are integrating a solar system within your campus with that of a DG set which is running in your campus. So if you go to any other contract or any other small time player or any other EPC contractor, they may not stress on this particular point more, but we take care of the technical aspects as well as the commercial aspects. So we, depending upon the situation in the client's factory, which will vary from person to person, we provide the solution, and this is one of the solution which we feel is very much suitable for AP customers because of the amount of power cuts which is happening. So what is a hybrid system? A hybrid system is something that is formed when you are combining two different types of generating sources. So it can be solar with that of the diesel generator. It can be wind in combination with the diesel generator. It could be any other source, even biomass in combination with solar or with that of the wind. So the complexity increases as the number of sources increases. So then it becomes a full-fledged microgrid, which is another area which we are working on. And the simplest form will be that of PV system, solar system in conjunction with that of the diesel generator, and some amount of intelligent management or control built into it. So the savings will be worked out. We can also look in the battery option. Now the battery will have two applications. One is if you are after the payback, very good this thing. After the payback, you are getting free. You can so those cases where the 3 years, 4 years payback is there, your internal rate of return I have seen going up to as high as equity return going up to as high as 30% plus. Exactly because of this reason, because solar lifetime is 25 years. It's not 5-year solar plant investment or asset. It will have a life of 25 years. So after that, whatever you are going to generate is going to come totally free for you, free of cost. So we can also look at the option of battery, wherein battery can have two applications. One is if you want to just use it as a transition between electricity cut to that of the DG, or you want to use it as a good massive storage, wherein some amount of hours are run from the battery, whatever solar energy is stored in the battery. So all these options can be worked out and given to you, and we will suggest a most economic solution which is suitable for the customer. So it's not that we want to sell the battery product, we will sell it to you, but definitely we will look which is more viable as well as technically suitable for the customer, and it is finally up to the customer to choose which one he wants to go for. So this is just a case study of what we have done in our campus. So this is the master plan of our campus, where we had planned around 1 megawatt to be put up in phases way back in 2008. So in 2009 we commissioned around 400 kilowatt. Currently it is around 800 plus kilowatt with different technologies. Different technologies, why I mean is, as you can see, this is the aerial photograph taken from a helicopter some time back. So all the buildings are mostly solarized. We have, you can see in the bottom, very unique BOS we had put, which was first of its kind in 2008, east-west facing. So all of us know, at least people in solar industry know that we go for true south-facing modules. Then why did we go for east-west facing instead of true azimuth south? We found that latitudes which are lower, that is southern states, if you put on an east-west configuration, the generation is more, and also you are fully utilizing the space available. So this we found the generation to be at least 6 to 7% more than true south facing. To find that out, if you see the third picture down,